This video is going to have a look at redox reactions, and redox reactions are anything that includes a reduction and an oxidation. And there are some rules in which we have to follow to identify which element is being reduced and which element is being oxidized. So let's start off with the basic rules. So this is the most simple one. Gain of oxygen is oxidation. It goes without saying, therefore the loss of oxygen must be reduction. This becomes less common as you go up the school, and we start using this one, which is oil rig. Now that stands for oxidation is loss of electrons, reduction is gain of electrons. It's a little bit trickier to identify, but it does get used quite a lot because we talk about it in electrolysis and things like that. Last one, loss of hydrogen. This doesn't really come up at GCSE. It rarely comes up at A level, but loss of hydrogen is oxidation, gain of hydrogen is reduction is another rule. Right, let's have a look at a very basic example. So I've got zinc here and I've got carbon, and zinc, the oxygen in this case, moves over to the carbon to make carbon dioxide, leaving the zinc on its own. Because the zinc is losing the oxygen, it is being reduced. Because the carbon is gaining the oxygen, it is being oxidized. Very straightforward. A little bit trickier here. So this is corrosion, this is rusting of iron. Now, iron, which is Fe, and oxygen, which is O2, I've balanced it out as well. When those two react in the presence of water, they form Fe2O3. Now, iron here is gaining oxygen, which means it is being oxidized. Now, as I said, you can't have a reduction or an oxidation without a reduction. You can't have a reduction without an oxidation. They're one and the same. They have to interact. They both have to be present in the reaction. So as a result, if this is being oxidized, the only other element that's present is oxygen, which means the oxygen is being reduced. There are other reasons for this to do with electrons. You don't need to know them at GCSE level because they're about oxidation numbers. But basically, iron is 0. Because oxygen is, as an element, it's 0. In this case, iron becomes 3 plus and oxygen becomes 2 minus in terms of its charge. And that's why. Okay, last one. So this is a tricky one. This is displacement of a metal. So this would be the magnesium displacing the iron in iron sulfate because it's more reactive. And it doesn't necessarily look like a redox reaction on the surface of it. But when you realise that sulfur here is a spectator ion because it stays as a 2 minus ion the whole way through, you then start realising that actually this reaction is written, and if you look at the reactivity series video I've done, this is explained in more detail, but it's actually written like this. So Mg2 plus Fe. Now what's going on here is the magnesium is losing 2 electrons, so it's gone to a 2 plus charge because 2 negative charges are lost. So that one has therefore been oxidized because oxidation is loss, and the iron has gained 2 electrons because it's gone from 2 plus to a 0 charge. Therefore that one has been reduced.